Okay, so solving trig equations, I'm going to go over this again in the next note, but for this note, we're solving for x. We're doing it the same way we would do anything else. We rearrange and then solve. But what we need to recognize is that we are using radian measure. Okay, we're not using degrees, so whatever was 180 before is now pi. Whatever was 360 is now 2 pi, okay? So when we're using radian measure, it's exactly the same rules. We still use angles in standard position. We still use cast. We still rearrange to isolate. We're just using a different measuring tool. Okay, so for this first one, we're going to rearrange for cos x equals, it would be -1 over root 2. I subtracted the 1 over and divided by root 2. Now what I need to remember is either the unit circle, which is probably better, but you can also remember our special triangles. We have 1, 1, and root 2. Okay, so what this is telling me first is that we're using, well, if we've got 1, 1, and root 2, that's going to give us our related acute angle. And 45 degrees is this triangle. But if we change 45 degrees, we should start memorizing pi over 4, pi over 3, and pi over 6. Okay, those are our special angles in radians instead of 45, 30, and 60. Okay, so we've got pi over 4 here. But what we have to look at first is where is cos, negative? Well, cos is going to be negative here and negative here. So our related acute angle is actually pi by 4. Okay, we don't even have to do the cos inverse because it's a special triangle. We know 1 over root 2 is going to be pi by 4. So then to find out x, we need to look in our quadrant. So quadrant 2, we've got x equals pi minus pi by 4, which is 4 pi by 4, minus pi by 4, which is 3 pi by 4. Okay, I changed pi into 4 over 4 so I could subtract. I used a common denominator. Okay, if you can just write the answer out. So if we went to, this would be pi plus pi by 4. If you knew that that was 5 pi by 4, that's okay as well. You don't have to write out all of those steps. Okay, so let's look at the next one. The next one, we've got sine x equals minus root 3 equals 0. So here, we're solving for sine x. We're going to get root 3 over 2. Okay, now for this one, we want to check our special triangles. We know that it's not the 1, 1, root 2, but it could be 1, 2, root 3. Okay, so if it's 1, 2, root 3, we need to have opposite over hypotenuse. Okay, this is pi by 6. This is pi by 3. So that means we're using related acute angle of pi by 3. Okay, again, that's the 60 and 30 triangle, but we've just changed it to radian. Using cast, we know that sine is positive in 1 and 2. We know then our related acute angle is pi over 3 because we're using opposite over hypotenuse, okay, for sine. So that would be this angle. So then in quadrant 1, we know that x has to equal our related acute angle, it's pi by 3. In quadrant 2, x equals pi minus pi by 3. Pi would be 180, and we're subtracting away our related acute angle. And this is 2 pi over 3. All right. So looking at this one's a little bit harder. But if I change that sine x, so if I do something like let a equal sine x, you don't have to do this. This becomes 2a squared minus 3a plus 1. Well, that's going to be 2a, and we've got what, minus 1, and a minus 1. So then this really says 2 sine x minus 1, and these are all equal to 0. And sine x minus 1 equals 0. Okay, I'm going to do the one on the left first. We've got sine x, or 2 sine x minus 1 equals 0. This tells me that sine x equals a half. Okay, now I've got a little bit less room here, but we're going to use that same special triangle here. Okay, except for this time, we're using here because we've got opposite over adjacent. So we've got pi by 6. All right, so going back, we've got positive sine x, cast, is in 1 and 2 again. Related acute angle is pi over 6. In quadrant 1, x equals our related acute angle. In quadrant 2, x equals pi minus pi by 6, which is 5 pi over 6. Okay. For the second triangle, or sorry, the second ratio, we get sine x minus 1 equals 0, sine x equals 1. Now that only happens at one angle. This is why the unit circle is a little bit better. That actually happens at 90 or pi by 2. So we would say that x equals pi over 2. Okay. When we're looking at this, the y value is always going to be our sine. So sine x equals 1. That means when is y equal to 1? Well, y equals 1 at 90 degrees. Okay, if we had sine x equals negative 1, it would be when is y negative 1? It would be at 270 or 3 pi by 2. Okay, if y or sine x was 0, that would be when is that? So it's at 0, 2 pi, but also at pi. I know this is a little confusing, but this is something that we need to either memorize or look at the unit circle and understand the unit circle a little better. If we did cos x equals 0, and that is in the next note, cos x equals 0 is when x is equal to 0, or cos equals 1 is when x is equal to 1. So cos equals 1 would be out here, negative 1 would be here, 0 would happen here and here. Okay? We have to look at these values and understand them. But for this case, we've got pi by 6, we've got 5 pi by 6, and pi by 2. And there's your question.